It's still Golang for beginners. So if you haven't subscribed, please go ahead and subscribe, like, comment. This motivates me, and also share. Someone out there might want to learn something, right? So I know my last video I spoke about algorithms and the importance of algorithms, not just in Golang but in different stacks, whatever stack you find yourself, right? And some of you guys have actually picked up algorithms and have also reached out to me, and I've solved one or two, but there's this particular algorithm I feel like we should revisit because um, it gives us opportunity to relearn what we have learned before on this channel anyway, arrays, and also talk about matrices, right? The name of the algorithm is diagonal difference, so you can check it out on your own. You can Google it. So as you can see, diagonal difference. So where do we start from? Like as usual, we start from reading and understanding the problem, right? It says, given a square matrix, calculate the absolute difference between the sum of its diagonals. For example, the square matrix array is shown below. Here we have a square matrix. So let me just put it out there. A matrix is just an array of arrays. Like as you can see, this is an array here. This is another array. This is another array. Or put them together in one array. So you're going to have a matrix, but don't worry about that. I'll get to that soon enough. So what this says is that the absolute difference, right? So you're going to have this plus this plus this minus this plus this plus this. That's 1 plus 5 plus 9 minus 3 plus 5 plus 9. So if you can see the example they gave here, they said 1 plus 5 plus 9 is 15, and 3 plus 5 plus 9 is 17. But when you're minusing it, you're going to have minus 2 actually. But in mathematics, when you have absolute difference, that means you're taking off the minus sign. So you're going to have 2. So put in mind that absolute difference is taking out the negative sign, right? So example, there you can read the constraints here. They have constraints, you can read it. So the idea is that try and read your question, your constraints, understand it, check the examples out. They have an example here, which is basically the same thing that they did up there anyways. They have an example here, and they have outputs here 15. This is the explanation that you get to understand. 11 plus 5 plus minus 12 4, and then you're also adding it with minus subtracting 4 plus 5 plus 10, which is 19 from it, and you're going to have minus 15, but it's absolute, so you're going to have 15. Then you go to your function, your function signature, which is, you can see it's taking an array of array, right? Because that's really what a matrix is. A matrix is just an array inside another. It's just an array of an array. That's just a couple of arrays, or an array or a couple of arrays inside an array. That's just what a matrix is, right? So let's switch to the code, our code editor. I like working on Golang, I mean, or you can use your VS Code, whatever. So like I said initially, this is an array, right? An array this is an array of integer or int32, whatever you want to have it. It's an array of 1 2 3. That's an array. And now a matrix is just having these arrays inside one big array. Like you have an array here. This is array 1, array 2, array 3, right? That is it. So now when you arrange this in a way, you are going to have here, this is the first array, this is the second array, and this is the third array, right? Because you're arranging it based on based on the first to the last. So that is what you have here. Sorry. So that's what you have here, an array, which is basically what you have here, right? So you can go ahead and try and solve this. So now we have already established the facts based on previous videos that an array, when you're counting in any programming language, you're starting from 0, right? You start from 0. For example, in this array, you're going to have position 0 1 2. The same thing. So when you are putting these arrays inside other arrays, you are going to have position 0, position 1, and position 2. So, and that's why you have it here 0, 1, 2 when you're arranging it. So now, inside those, keeping in mind that this is an array inside an array. So when you have position 0, position 1, and position 2 here, we also have inside this array, we also have position 0, position 1, and position 2, right? So we also have position 0, position 1, position 2, position 0, position 1, position 2. Let's keep that in mind, right? So now let's go to the function. So now what this means is that if you want to have access to this whole array, the position of this whole array is position 0. Position of this particular array is position 1. Position of this particular array is position 2. But if you want to have access to this number, the position of this number is position 0, of position 0. I don't know if that makes sense. So if you're going to have access to this number 2 here, it's going to have the position 0 of position 1. Since inside this array is the position of 2 is 1. This is 0, this is 1. If you're going to have access to 3, it's going to be position 0 of position 2, which is 0, 1, 2. Same thing here, likewise. If you're having access to position 4, it's going to be position 0 of, position 1 of position 0. Because this is 0, this is 1, this whole array is position 1, and this is position 0. Likewise here, it's going to be position 1 of position 1. So likewise here, if I'm going to have access to this line, it's going to be position 2 of position 2, which is 0, 1, 2, 0, 1, 2. So this is 2 of 2. So keeping that in mind, right? Let's switch down here again. So keeping that in mind, you can tell from the question, all you want to do, you want to add this plus this together and subtract it from this plus this plus this. So now, knowing the positions, knowing how to have access to each of the elements by their position, you can easily do the subtraction and whatever you want to do, right? So now you can see that for you to get 1, you're going to have position 0 of position 0. For you to get to 5, which is this, you're going to have position 1 of position 1. For you to get to this particular 9, this, because you're going this diagonal here, for you to get to 9, you're going to have position 2 of position 2. I've explained that here, 0, 1, 2, and this is 0, 1, position 2 of 0, position 2. So that is that, right? Getting this position, right? This is position, this is going to be position 0 of 2, this is going to be position 1 of 1, right? Yeah, and this is going to be position 2 of 0. So you can, so having that in mind, right? Let's jump into the solving the equation, right? Which I have it here. So don't worry, I'm going to just explain this. I'm going to try and explain this to the best of my abilities, one after the other, so that you can understand and follow along, right? So if you have an issue following along, you can always drop a comment in the comment section. I'll pick it up, right? I'll pick it up. So there's really nothing there to it. So now, first of all, this diagonal difference, right? I've solved it, but let's comment out this, right? So that we can get to see what I was talking about. Let's also comment out this answer, right? That is answer. So now, let's start from here, right? Let's start from here. Let's print. For example, this is an array, like I explained before. This is an array of ints. This is actually an array of ints, right? You can also do an array of int 32. Doesn't matter, right? Int 32. So now, so you can see the difference between an array and a matrix. This matrix of length 3. So you're having, this is the length. The length of the matrix is the length of any array or whatever is the number of items inside that array or inside the matrix or whatever. And but then don't confuse the length with position. Position is different, length is different. Length is, you can easily just say the length of this array is 1. The length of this array is 1, 2, 3. Also, the length of this matrix is 1, 2, 3. But when it comes to position, the positioning starts from position 0. So now the positioning is 0, 1, 2. Also 0, 1, 2, 0, 1, 2. So please, let's not get confused there. Put that in mind. If you have any question, you can always reach out. So now, if you are going to print this, let's just do go run. I think go run main.go. No, I think we're in the wrong directory. We are in the wrong directory. Hold on. Yeah, sorry, we're in the wrong directory. CD. Okay, let's do go run again. Go run main.go. Yeah, you can see the array. This array is 1, 2, 3, and the matrix is this the representation of matrix, this which is just an array of an array. You obviously you have to specify the type, so you now put the different arrays inside one big array. So we now have a matrix of this, right, which is basically the same as this, right? So get that, which is basically the same as this. So now, just to let you know the positioning thing that we spoke about, right? Let's print our position here, right? Let's just do, you can always copy and paste this. Let's print out position. Let's do position 0, 0 of 0. Let's do position 0 of 0. So you would see that for this matrix, so if you're going to do the position of matrix, you have to do position 0 of 0. So when you print that, you're going to have 1. So I'm just going to print it one after the other so that you can get to see what I'm talking about. As you can see, position 0 of 0 is 1, which is 1 here because it's inside 0. So if you're not saying, let's print position 2 of 0, which if you count it, it's going to be 0, 1, 2 of 0, which is going to be 9 here. Going to be 9 there. So if you're doing 2 of 0, sorry, let's correct this, 2 of 0. Okay, that's go run main.go. That should be easy, which is 9. So now you can understand the positioning inside an array and matrix, right? So now let's go to the function proper. We can take this out, right? We don't really need it anymore. We just wanted it just to explain a couple of things, right? You can always take this out. We don't need it, but this is what we do need. We do need this. So I've explained function before. This is a function, right? So I'm just calling this function here and the answer, and then logging out the answer here. So it's really not a problem there. So now, first thing when you're doing like this, for you, as you can see, this is the signature of the function I was giving. This is diagonal difference, having an array of an array in int32. It's the same thing, array of an array of array in int32, an array of an array in int32. This is diagonal difference. That's the function, So first thing you will want to do is I always advise try and initialize your container, which will serve as your answer, right? This might actually serve as your answer. So when you have and then you do know you're expecting int 32 here. So when you create a container, maybe I should rename this to answer, right? We rename this to answer so that we should not be confused. Rename answer, right? So we should not be confused, right? So you create a container which will primarily hold your answer, which is in 32 here, and then and then just come here and return it. It's as easy as that. Just come here and return it no matter what. So you know that you are returning an answer of int 32. Then with that, you can now start solving whatever you want to solve here. So now there are two things you need to understand, right? You need to understand that you need two containers again, two variables that would hold your first diagonal, which is you're going to hold the answer of, let's say, 1 plus 5 plus 9, your first diagonal, and also hold this answer of 3 plus 5 plus 7, second diagonal. So yeah, that's what I did. I initialize, and we're working with in 32 years, so you also initialize that. Yeah, this is diagonal 1 for answer 1, and this diagonal 2 for answer 2. So solving algorithm is all about your thought process, right? How you envision the problem, how you understand the problem, how you go ahead solving the problem. So like what I've explained here is that we have actually initialized like three container. The first one is to return the overall answer now, which is what we are returning here. Return the overall answer, which is in 32, obviously. And then the second one here is to pull the answer of each diagonals that we are going to add together, right? So now I know we have done looping before, but we haven't actually done looping working with matrices. So now I I I explained this, that what we are trying to do is we're trying to get the value of this position, right? So now if now work with me, right? Let's go back to here. If you look at this, you can tell, like, you try and find a relationship between each of those numbers, right? That's what you're trying to do. That's where your thinking comes in. You're trying to find the relationship between each of those values. For example, you want to add 1 plus 5 plus 9 together. So how do you do it? What's the relationship between 1, 5, and 9? That is, this is 0 of 0, this is 1 of 1, this is 2 of 2. So now when you come down here, you would realize that this is simply when for in a for loop, when I is 0, right? Obviously you're doing I starts from 0 and less than the length. As you can see, the length here is 3. It's going to be less than 3, and then you go I plus plus. If you don't understand looping, you can check my previous video. I explained that in details. So now what you're trying to do, that when I is 0, right? Let's get this straight, that a right now a is 0, right? The 0, when you initialize a container or whatever, or a variable, it takes the negative value. For example, if you're initializing a bool, it's going to if you it's going to take the false value. So if you're initializing an int or in 32, is going to take the 0 value. So what we're trying to do is if you're initializing a string without anything, is going to take an empty string, right? I think I've covered that in previous videos, so please check that out. So now for now we know that a is actually 0. So what you're doing here is you're adding, so you're taking the value in this position. For example, when it's 0, 0 of 0 is going to, from here, 0 of 0 in this is 1, exactly. 0 of 0 here, position 0 of 0 is 1. So when it goes to the next, when it goes to the next ranging, which is going to be, this is going to leave 0 to range 1. So when I is 1, you're taking I 1 of 1, which is 5. When I now goes ranges 0, 1, comes here to this, is going to take position 2 of 2, which is 9. Now take note that you are arranging the matrix. You're arranging through the matrix, not the array. So you're counting this, you're seeing this whole thing as I is equals to 0, I is equals to 1, and I is equals to 2. So, and now the relationship is, when I is 0, you want to take 0 of 0. When I is 1, you want to take 1 of 1. When I is 2, you want to take 2 of 2, right? That is the idea. So that's why we have So now, for example, now you're adding. So whenever you range through it, for example, I'm looking at the A here. Whenever you're ranging through it, it starts from zero. So when you're adding zero plus, for example, one, you're going to have one here because one is I of zero is one. So you're going to have one. So when you range it again, it goes to I is equals to one. So it's going to be one plus array of 1 1. So it's going to be array of 1, which is going to be 5. It's going to have 1 plus 5 is going to be 6. And then when it goes, if it ranges again, and A is going to be 6. 6 plus, keep in mind that this is going to be probably be 2 right now. So it's going to be 6 plus array of 2, 2, which is going to be array of position 2 of position 2, which is going to be, which is 9. 6 plus 9, that's 15. So that is how you get your 15 for A. Now, for B, it's a bit tricky when it comes to B, right? For B, it's a bit tricky because B, you need to think about lots some things. You need to have your you need to think about it critically. For the A, it was actually easier to just have I of I and then get it over with. But for B, it's not going to be just I of I. You're going to need to do some thinking. So for example now, for here you can see you're taking the array of I because obviously you're looking at the first one you want to take the last item here, right? You're trying to take the last item of the array here. And now, so what you're doing when you are in I, we're taking array from zero. So you have to zero of now the second index that you're looking for would be the length of that array, which is 3. For here you can see that the length of this array is 3. The length of that array, which is 3, minus I itself, and then minus 1, right? For example, now what you're trying to do is like you're trying to, for example, when this position is 0, right? Position is 0. So you're trying to find this. You're going to say the length of this array, which is 3, which is probably like 3. You subtract the position from it, and the position is actually position 0. You subtract the position from it, which is actually position 0, right? Which is position 0 subtracted by from 3. So you're going to have position 0 minus 0, and then you do know that the length to find the last item in an array is basically the length of that array minus 1, because keeping in mind that you start counting from 0, 1, and 2. You start counting from 0, 1, 2. But so for you to find this last item, you have to minus 1 from it. So that's why you have 3 minus 1, right? So ideally, this would give you the last item here, since if of index 0, right? But why you're subtracting it from I, which is 0, is because it's actually because once you get here, you cannot just do 3 minus 1, because you're not just looking for, when you get to this one, you're not just looking for the last item, you're actually looking for this item here. You're looking for the item in the middle. So for example, now when you get to index 1, you want to, after you get the last item, you have to minus 1 from it. You have to minus that index from it, which is 1, which is index 1. That will give you this 5. Same thing when you get here. Once you are getting the last item here, which is going to be 9, you need to minus 2 from it for you to get this first one, which is going to be index 2. So I don't know if that makes sense. If it doesn't make sense, you can always message me. So let's just go back to the code. So for here now, you're having, obviously, for the first array, you're going to have the length of that array minus 1, and then you minus from the index, which is I. So for the first one, I is going to be 0. So you're actually getting the last item of that index, of that particular index, the last item of that particular index. So for the second one, the I is going to be 1. So you're getting the middle item. So once you do the, when you get the last item, you minus it from the index, which is going to be 1. You get the middle item. So, and also for the last item, which is going to be position 2, when this is equals to 2, you are going to we are going to get the last item minus 2 is going to give you the first item, right? So we are going to I'm going to print this. We are going after this. I'm going to print A and B here out here so that we can see what A and B is, and what I'm doing here. I'm going to subtract A from B, and yeah, and because we're not just subtracting, we're having the absolute value. So when if A, so I'm saying that if A is negative, if the answer is negative, that's if answer is less than 0, which is negative, then what we want to do is want to multiply 1, want to add it times it by 1, which is going to give you, which is going to multiply the minus from minus and is going to take away the minus sign, right? So let's run this code and see what we have here. So we run this, go run main.go. Taking a while. All right, as you can see, the answer here is 2. What you're having here is 15 minus 17, which is supposed to be minus 2, but you're going to have 2 here because that's the what do you call it? That's the absolute difference. Because of what we did, we multiplied by minus 1.